I have an oscilloscope to review. This is the Hantek 5000 series scope, DSO5202P. This is for free from Banggood for review, so there you go, here's a sticker. Thank you very much Banggood for sending that to me at no cost. There'll be links for this thing down below. Please follow links if you're interested in looking at this particular scope or anything else on Banggood, because it helps to support my channel. Let's get stuck into it. Depth adapter there, you always need a depth adapter. You have a power cord, which is a European I believe, which is no good for me, but it's just a standard IEC cable, so no issue there. You can just see the plug in there maybe, so I'll just use a standard IEC cable, not a problem. We have a guide thing I'll have a look at in a second. Got some probes, which are 200MHz probes, because it's a 200MHz scope. Got two of those, and they have the basic accessory kit. They don't have the full kit. Yeah, there's no spring clip probe and there's no BNC adapter, unfortunately. It's just the basic kit. You can buy the BNC adapters and the clip probes yourself if you need to get them. There are sources for those. Can be hard to find, but they're out there. Okay, so that's those. And let's have a quick look at this manual. So you've got a CD in there, warranty card, maintenance record card, yeah, just warranty stuff really, and packing slip. So obviously the manual's on the CD. Get it out. Oh, also I missed something. And the depth adapter just landed on my foot. Fell off. Ouch. Luckily it's not very well made, so don't weigh much. Don't get much. Let's unpack this thing. Let's have a look at the back first. I did kind of show some mailbag already. So we've got a USB port here, no LAN port, it's not populated. So we've got a USB port on the front here. I'm not sure what that functions for at the moment. So it's 200MHz, 1 gig of sample per second, 2 channel. So it might drop to 500 mega samples per second when you got both channels running, I'm guessing. We'll find out. Channel 1 and 2, external trigger port. We've got a calibration port here, which is 1 kHz square wave probe check. Not sure what that does. Force trigger, 50% trigger, trigger menu, trigger level. That's just a basic pot, nothing too exciting. It's not indented. Not indented, not indented, not indented. Those are indented, the volts per divisions, and the seconds per division are indented. So we've got one stop, auto set, single sequence, display, acquire, measure, cursor, utility, save, recall, as you pretty much usually get anyway. There's like a multifunction knob here, which is also pushable. All the buttons apart from the volts per divisions are pushable. These aren't pushable. That one is. That's a shame, because that's like a potential option they could have had in there. Could have made it pushable and made it a fine tune. So we've got help, default setup, save to USB, F7, F0 through to F6 and F7, so function keys, which is interesting. So you've got soft keys. It's also marked as mode down here, and menu on off up here. That's not as obvious, but it's marked on the casing there. You can probably just see it. Okay, so that's the front panel controls. Okay, power is applied. Let's push the button, see what happens. Okay, you got some test lights on the buttons. It's like 6 buttons that light up. Hantek the QR code. Interesting. That's a pretty quick boot up time. That's fast. So let's check out the screen angles. It's not too bad. You can see it's starting to fade off a little bit there. Downwards isn't too bad. Upwards is pretty good actually. That's not bad. So the angles are pretty good on the LCD screen. That's quite an important thing to consider when you've got a piece of gear like this, like on the shelf. Might be looking upwards at it very slightly, sort of thing. Let's get a scope probe out and settle that up. Although I can't see any graphicals on here. Display menu, contrast, vectors, dots, persistence. Okay, page 1 of 2. I keep wanting to do push buttons. Right, okay, so intensity. That's pretty easy to use, isn't it? Here we go. Turn up a little bit. You probably still can't see it on camera very well though. Can you get it? Maybe I'll tip this thing back a bit, that'll help, eh? Let's get this feet out. So I'll get this, unhook these. I'll tip it back slightly and hopefully give a slightly better view. That'll make it basically straight onto the camera now. But that's all the way up, the intensity. It was on. I mean, I can see it myself, but obviously on camera it's not really showing up. The lighting's washing out a little bit. Right, let's get a probe out and calibrate the probe and have a play. Okay, probe pack. It looks like these are sealed, so I've got a pair of scissors out. Let's cut this thing open. It's like it's welded shut. I suppose it's a good thing so you can't lose parts from the factory. Right, let's see if this does it. It's got a strip on there, it's not even attached. There's nothing on the other side. That's an interesting probe pack. I've never had one which hasn't had the strip on the other side. So it's got the strip there for resealing, but there's... what the hell? That's just weird. I don't know. Right, let's get it out. Let's look at the specs of the probe. So we've got the PP200 because it's 200 MHz. Make sure, yeah, PP200, it's on there. So you've got standard specs, 10 mega ohm, 1 mega ohm times 1, and 10 mega ohm times 10. 1 mega ohm. So this is the thing you got to watch out for with scope probes. This isn't something which is always told to you about the way these probes work. When you're only at 1 times mode, your bandwidth drops significantly. So this is 1 times mode is DC to 6 megahertz, which is typical. That's what a lot of probes will do, you know, or something in that region. And times 10 will give you the full bandwidth up to whatever the probe is designed for. Something to watch out for: if you're doing 1 times measurements on your probe, you're not going to be getting your full bandwidth. You might be getting false results. It's something to watch out for. Also, your voltage levels available are also reduced. This is actually quite generous. 200 volts and 600 volts. Depends on what your scope can actually do, that's the main thing there. Packing list as well, says what comes with it. Nothing that exciting, but yeah, okay, so we know what the bandwidth limitations are and the voltage limitations are of the probe. No issues there. The scope itself is 400 volts Cat 2, apparently. That will be at 1 mega ohm input, or whatever the hell it is. It's probably 1 mega ohm input. Anyway, this probe has got red bands on it right now, but you don't want to change that because we're going to be going to channel 1, which is yellow. So we'll pop these bands off and change these to yellow ones. Just because I, you know, want to make sure it all matches. I'm fussy like that. I'm not OCD at all. Honest. Really not. No. No. Anyone says that is insightful. Yes, the band's changed. Now we can plug it in. It's a nice tight fit. So let's see about setting the probe up. So we want it to be on 10 times on here. I've just done a video about probe compensation, so setting it up. So if you haven't seen that, maybe go and look at it. It might give you some other information. So we're currently on what? DC. I want to do AC instead, so it's nicely centered. That's the waveform we want from that. We need to calibrate this probe, which is done probably at this end on this particular probe. Yes, it is. So some probes are done on the actual probe itself, on the probe handle. Other times they're done on the connector end. This one's not the connector end. So where's the screwdriver gone? I had it here. I've lost the screwdriver. Okay, found it right on the Heathkit. So what we've got to do is set this waveform up to get it as flat as we can on the upper and lower parts of the waveform. Currently, as you can see right now, it's overshooting. So if I do 1 times, you'll see it's flat. Okay. The compensation is when you're at the 10 times setting. So bring this up. You see needs adjusting. So we'll get in here, we'll get in that little hole that's in there. Try and get my hand around at the same time so you can see what I'm doing. And we turn the little adjustable capacitors inside the connector. So you can also set it to undershoot. But generally you want to get it as flat as you can. And it can be a bit hard to judge sometimes if it's undershooting or overshooting. It's right if it's on lines, you can actually see the line, follow the lines. I think that's pretty close, just there. If I change the time base, I might be able to see it a little bit better. I think that's all right. That'll do there. Close enough. So one of the other things that came in the scope pack is this little probe cup here. So you can put it onto like an IC leg, for example, and the probe then is less likely to slip off. Let me just unhook this and show you. So I pop that off there. Pop this off here. So there's the probe tip, and you should be able to put it over the tip of the probe like this. And then you've got your probe tip sticking through in there, like that. Which means then you can probe around circuitry without worrying about the outside of the probe shorting things out, or the probe tip slipping off and shorting something out. This means you can put that on a component leg, less risk of shorting things out. This could still happen, but a bit less likely. That's what those are for anyway. So let's start having a closer look at this thing and see what features it actually has. I have no experience whatsoever with Hantek scopes. I'm used to using Siglent. I've used my Keysight as well, obviously. I've not used Hantek gear before, so I'm not that familiar with their user interface, that sort of stuff. So it should be interesting for me to try and find my way around as well. So we both can explore this thing together, I suppose. So where should we start? Well, we should start at the top left. So we've got save recall. This is we've already established as a variable thing for doing various functions, for switching selections. Save and recall, reference, setup, CSV. Let's do a CSV. You can do save, recall, delete, and there's also a file list. Close and open. Open. I don't have a USB drive in right now, so you won't see anything. So I won't go too deeply into that, but that's fairly obvious. And you got channel 2 as well. So you can store probably waveforms, most likely, and get back. So reference waveforms, setups, and CSV. So reference waveforms, so you can use it as a pass-fail kind of thing. If you have a waveform it's definitely the correct one for a piece of gear, and you're doing multiple pieces, for example, you can have a reference waveform is correct, and then you can use that comparison on other pieces of gear to make sure they also match it. Setups, so you can save the setups for this device. If there's a particular way you use it all the time, you could store that as a setup, and then you can recall that so it always comes back in the same state. Sometimes you can save them to buttons as well. I don't know if this can do that. Default setup, maybe you can save it to that. It's possible. This says 0 to 9. USB flash local memory, so you can store local memory ones as well. And CSV will be probably the waveform that's on the screen right now, so you can do that as a reference or something later on. Okay, let's close that menu. Measurements, so you've got cursors most likely, I expect. So this is this is the on-screen measurement stuff, so it tells us what the various waveforms and what have you are. So let's get this thing triggering on something. Let's plug this into something and get some kind of measurement to actually look at. Okay, so I've taken the probe off. I've put a BNC cable going straight to my Marconi signal generator, which is currently generating a 10 MHz waveform at half a volt. That's into 50 ohms. So let's see, do we have a 50 ohm menu in here? I didn't notice that actually. We don't. So this might only be 1 megaohm. I think it's got 50 ohm inputs then. So the readings we get here won't be quite right. But we are measuring 10 MHz indeed here. And here we're saying exactly 10 MHz, but I think this is a bit fake. So let's try putting in 10.001 MHz for example, and that should show up here. Right, so we need 10.001 MHz, and actually it does show it. I'm actually surprised, it does actually show it. We're now doing 10.0015 MHz, and it's showing there as well. I'm actually impressed by that, that's accurate. So this must be a hardware frequency counter, and this is based off the waveform. So if I bring the number of waveforms into this display, it might get more accurate on here. So I'm actually impressed by that part, that's good. So let's see if we can change what measurements we can do here. Now notice there's a modifier at the bottom here, so let's push that. Oh yeah, okay, so we can change what we're measuring. RMS, we can do that. Oh, I'm jumping all over the place here. Let's go back, hold on. I've done something silly here, I think. Because it's a scrolling menu. Okay, right. Let's got heaps here. Heaps of measurements in there. Loads of them. Cyclic RMS, I like having RMS measurements. Can I select that? Yes I can. So we've got mean, cyclic RMS, mean, peak to peak. Yeah, cool, those are my usual ones. What else have we got in here? Period, frequency, we've already got frequency in there, haven't we? So let's go back. So we've got frequency at the top and down here, so you can see I put it back 10 MHz again. So that's nice, that's easy enough to use, it's pretty simple. Choose the measurement you want. Rise time, pulse width, things like that I don't tend to use myself. They can be handy, but it's not. I only tend to use those when I'm doing calibration work. That looks right. So let's try a little test. One of my tests are to use a 10 MHz signal with a 1 kHz AM modulation superimposed on that. And the test is to see if it can see the AM waveform. Now usually you have to do things like use hold off. That will be in here somewhere, probably on an acquire menu. There's an acquire menu up here, which might give us hold off options. We'll see. Memory depth, let's increase memory depths. It's 4K, 20K, 40K, and the other ones are currently not available. Can only do 40K there. Let's do the frequency. Does this change with the settings on here? Those aren't changing. Memory depth is only 40K. For some reason you've got the other options which are grayed out. There must be something else. There's probably a setting which allows that. Maybe using averaging or peaking or something like that. No. Number of averages. Average is good for getting rid of noise. Per normal EQ time. Don't know what that does. So that's the acquire menu. That's the measure menu. Right, what was I going to do? Oh yeah, I was going to check this waveform. See what we go with modulation on it. Right, so I now have AM modulation turned on at 50%. So you can see there's some jittering on the waveform now. That's correct because there is a waveform going on there as well. So let's see about changing this to find that waveform, see how it comes out. Yeah, we'll get Nyquist stuff going on as well. That's likely to be it. That's 50 Hz, so that is not one we want. It should be 1 kHz, so it should be something around here somewhere. It's just trigger levels. Does it have hold off? Hold off is kind of what I want to find. I didn't see it anywhere. Memory depth's also changed again. Let's increase that back up to a larger value. That's measuring 50 Hz noise, which is, you know, normal for here. I get a fair amount of noise here, but I just want to see if I can find this waveform. Let me see if I can get it going. Okay, so this is with 99% modulation. I can now find something on here. Okay, and it is reporting kind of right 1 kHz. So it is finding it there, but obviously the resolution's not good enough. Memory depth again, let's jump back down to 4K. I mean, channel 2 is not even on. Bandwidth limit, I'll turn it on. Shouldn't really matter. This one, the 20 MHz bandwidth limit. But yeah, I mean that's what I'm getting. So if I bring the level down some more, you can kind of see it. Play the triggering, you might be able to get it a bit more reliable and get it on the edge. Here we go, just about there. Kind of. Yeah, so no hold off could be a problem for some things. It may be that it does have hold off in here somewhere, I just haven't found it. Don't know yet. I've tried the horizontal menu, doesn't appear to be in here. Page 2. Oh, there we go, there it is. It is there, there we go. Right, let's increase this. This velocity control, looks like it might be. This can be a bit fussy to get set up. That's why it's a good waveform to test on. It's drifting very slowly, but it gives you an idea. So it's not perfect triggering, and I can actually change the trigger level up and down a bit to try and maybe move it around. But more centered, it seems to be working better. Okay, so it will do it, but it's not like my other scopes. You can't really see it in the same way. So there is a persistence option in here. So I did just go and look at that, and you know, it does actually work. Infinite persistence, so this gets messy. So that's good if you're trying to find little glitches. So it does have that feature in there. And there's an auto mode, which means it adjusts itself depending on what you're doing. Let's look at this contrast. Oh yeah, so it's main display contrast. I'll turn up a little bit, it probably makes it easy for you to see, doesn't it? That second page in there. Good intensity, which we also looked at. Frames, refresh rate, auto, wave intensity. Let's increase that as well, shall we? Because we can actually bring the waveform up and down. I'd rather have maximum intensity on the waveform because it brings up every little bit. So that's your options. Dotted lines, grid lines are off. So I think I prefer dotted myself. Refresh rate. So look at this. 30 frames, 40, 50 frames. Must leave on auto. Okay, right. Let's keep looking. So another feature I found just by stumbling across it is this F7 button. Push that, it gives you a split display view. Because this seems to be like a magnified view of that one. I suppose it captures the full part of the waveform there, and you can see a slightly zoomed in view. So I suppose it is doing a slightly zoom view. Yeah, okay. Okay, let's play this a little bit now. I'll just switch this from fine to coarse. And then I took it back out again, and then went back in. And with fine, it is actually doing a proper zoomed in of the waveform there. It is actually doing it. So yes, you got the waveform there, and then here we've got this. So there must have been a setting in here somewhere. So I couldn't get the waveform I actually wanted on here. I should get like an eye diagram, you know, so this sort of crossing over. I can't seem to get that particular waveform in this scope for whatever reason. I mean, what I'm seeing here is kind of right, but you should be able to get a different waveform from that, and I can't seem to get it. I'm not sure what the story is there. We have utility. Let's have a look at this. What's in here? System information. Gives you the model number, software revision, that sort of stuff. Boot count 0. Well, I think I booted up once because, you know, it's running now. Okay, what else you got? Firmware update. You can do that. Save waveform. Printer not detected. Printer. Self-cal. I'm not doing that right now. Press F4 to cancel. Next page. Keypad beep. Oh yes, turn that on. People hate it, but I like it. Language. Oh, yeah. It toggles as you push the button. That's English again. GUI? Oh, I can change the colour of the GUI. Oh, Eve. Oh, green. Pink. I don't like the blue. I actually prefer the black. But then some of this other stuff grows out too much. Is that an issue? Oh, I don't know. I don't know. That pink's looking quite good. What do you reckon, Clive? Clive, you there somewhere? I actually think the black is slightly easier to look at than the blue, because some of these icons are disappearing in the blue. Blue is actually a really hard colour for you to look at for sharpness. Blue is not a good sharp colour. Having a different interface other than blue is probably going to be better. So this is black, but it's also like more of a grey really, but I actually think that looks slightly better. I'm going to leave it on that. Time, well, we're not currently set to the right time and stuff, but yeah, I'm not going to worry about it right now. System status, sample rate 50 kilosamples per second. Okay, so it gives you a bit of information about what's going on there. Pass files turned off, that sort of stuff. Okay, next page, pass file, turn on off. Don't need that right now. Stop and output. Must use an external trigger as a pass fail. Could it be? I didn't see a connector on the back. Did I miss something? This is going out of USB. Maybe it's using the pass fail out of USB, that's possible. Pass fail mask apparently. Except that one. Back in here. Here now. Recorder. Function. Play, record, save. Okay. Oh, let's go back, can I? No. Filter. Yeah, I don't need that. Just 7 go back? No. I would have thought F6 would go back. Apparently it doesn't. Let's go back that way. Printer configuration. So yes, because it's got a USB output on the back and on the front here, I guess it means you can print to a USB printer. That could be anything you print away from, I suppose. Back. Now you've got a back button. Options. Video. Did grayed out. Board. Siglent. Okay. Can't seem to switch that one. Wave. What is this doing? Don't know. Save. Okay, save and recall waveforms. Okay, right. There. Cursors. How many cursors does this thing have? Off. Time. Okay, so you've got dual cursors here. For that one, voltage will be vertical ones. Which are here. Tracking cursors, which means it automatically looks at the waveform and tries to figure out what's going on. Which is getting messier and messier, interestingly. Sources, display, we looked at this one a little bit. Did we cover it all? I think we did. Auto set, let's chuck that on so it makes it a waveform. That's kind of right. We have to measure, see what it's thinking. 10 megahertz is getting there, so that's the waveform it's doing there. So 10 megahertz waveform which is being modulated, so yeah, it's kind of right. So what I've done now is I put it to dots display, and let's just see what the dots are. It still appears to be doing vectors though, because you normally expect to see individual dots. I mean, you can see individual dots here, and those dots tell you the sample rates, basically, where it's taking the samples. Yeah, I'm not convinced about that one. It still seems to be doing vectors with dots when you go to certain speeds. So that's doing dots there. That's still dots. That is dots. That's looking more like vectors. No difference. Yeah, it's doing dots there. But when you go past in 20 nanoseconds, it still goes to vectors. Interesting. Okay, let's go trigger menu. So look in here. So we've got edge, video, pulse, slope, OT, whatever that is, alternating, source, obviously, rising, falling edge, auto, normal triggering, coupling, AC/DC, noise rejection, HF, reject, no frequency reject, 50% position here. But I'm on AC coupling, so it probably won't matter right now. This is DC coupling for triggering. Triggering is DC coupling. Because of the auto set, it's changed some of these settings. Trigger position. That is jumping back to 0 point. Force trigger. I guess that's if you maybe stopped it. No. Single. No. Okay. Horizontal menu. Okay, you can change what each window is doing. Right. Maybe that's what I did before, is I changed that setting for that window, which is why I suddenly got that zooming working properly. And we've got different hold-offs on each one as well. What else we got here? Yeah, whatever. Get out of there. Somehow. Won't let me get out of there. Turn that back off. Right. Math menu. What's in here? Addition, subtraction, one from the other. Multiplication, division the other way. Addition, scaling. Okay, so yeah, it's got an extra waveform on there now, showing that. Let's turn this modulation back off again. That way we get a sensible waveform we can actually look at. So because there's nothing on channel 2 right now, it's going to be giving a different kind of waveform. It's adding 1 and 2 together. So therefore it's actually taking an average, which is what the purple waveform is, because channel 2 is not even turned on. Interesting, you can do a calculation of waveform which isn't even there. That's pretty clever. Okay, what other options here? FFT as well, it's got FFT in it. This whole scrolling menu thing's a bit of a pain, because then you don't actually realise it's scrolling. It's not very obvious. It's got FFT. Okay, just down here it's giving us a note here, 2.5 megahertz, 50 milliseconds per, so mega samples per second, I think that's saying. So if I change the horizontal bandwidth here, it's now doing 1.25, and I can move it around. 500 megahertz, 1.25, 2.5 gigahertz, 5 gigahertz. Really, that's optimistic. Okay, well, let's bring us down to something a bit more realistic. Let's go down to 500 megahertz. Okay, that's maybe possible. So I've got the carrier obviously at 10 megahertz right now. Let's go to 100 megahertz, see what happens. Okay, just over there, 200 megahertz. It's over here, 300. Disappearing. Okay. Okay, right, this makes kind of sense here. Oh yeah, okay, right, now I've got it. There's a marker here. Right, that blue marker there's given the frequency of the centre point. So I've got a 50 megahertz signal coming out and it's right there. So okay. Okay, a bit more sense now. So this number down here, 12.5 megahertz right now, that is per division rather than span. I'm thinking of span because of spectrum analyzers. But that's per division, 25 megahertz per division, so I can actually bring it down to say 50, 125 megahertz per division. So I could go down to say 2.5 megahertz per division, and then see if I can move it over. but you see it cuts off up here. Obviously its resolution is a bit different. Well, the other settings in here for this, apart from the types, got ×1, ×2, ×5, ×10. I'm not quite sure what those are referencing. So that's sitting at 20 megahertz right now. Let's put my generator 20 megahertz. Okay, it's 20 megahertz there, and the spike is right there. There it is. So it is reading those frequencies. So that's 50 megahertz per division. So in theory, that should be 250 right in the middle, 500 up there. So let's have a look. Let's do 150 so I can see it. That's over here. Got all this noise here as well. So that's 50 per division. That's 50. 100, 150. Let's go 200. It's there. 250. Should be behind that line. It is. It's there. 350. Let's go to the other side. That's just there. 400. Yeah, it's disappearing now. It should be over here somewhere. But that's kind of the limit of where it's going to go. We're back to 250, which is smack bang in the middle. Okay, I've now put on a T with a 50 ohm load just to try and get the matching correct and see if that changes anything here. So I'm sitting at 250 right now, so you can't just see because it's behind that white line. Let's go back to 350 again. That's over here. 450, which should jump up to over here, and I can't see it all. So that's not surprising though. It's a 200 megahertz scope, so the fact it's even here at all is quite good. 200, it should be right here. There it is. 100. Should be there, yep. And I'll do 50 next. There. Okay. So now I've got a 50 ohm load on there. You can see I'm getting 512 millivolts in RMS, which is my generator set to 500. That's actually about right now. Well, my generator on here is giving 940 millivolts. That's at 13 dBm, which should be 1 volt. So obviously it's not perfect matching. It could be this load is slightly off. Maybe it's 49 ohms, not 50. Could be something like it. Could just be this is not quite accurate. Could even be my generator output's wrong as well. It's also possible. That's at 70 megahertz though. So yeah, we'll 72 megahertz sitting up right now. That may be something to do with it as well. Let's change frequencies. Let's go down to 10 megahertz for that. So the generator I'm using now is a Rohde Schwarz CMU 200, and it's at 840 there. So it's actually gone down. I don't guess it's through a BNC cable too, so it's kind of alright. So trying to get this 0.707 reference level to get the 3 dB point is going to be a little bit tricky because it's definitely varying around with frequency a little bit there. So we're getting 860 there, 50 megahertz. So if we go 100 megahertz, you're getting 1 volt there. Okay, so that's good. One that's right. Alright, so that's basically correct at 100 megahertz. Just slow it down a little bit there. But you can see there's a bit of jitter in that signal, which is interesting. This isn't modulated. So maybe it's picking up some 50 Hz noise, I don't know, maybe. So let's do 150 megahertz. Voltage actually increased, 1.3 volts now. Let's go 200 megahertz. 980, okay. 250 megahertz. And it's jumping over the place. That'll be the dot mode resolution thing. So that's close to 10 dB point, right? It's sort of jumping around at 700. Let's see if we can find this setting. Memory depth, 40K. Okay. Not sure what its real time EQ time thing is. Don't know what that is. So if I do averaging, that'll smooth it out a little bit as well. You can see it's jumping around. So it keeps jumping back to this 4K memory depth. Obviously it doesn't have the high memory depths on there, which is interesting. Anything else I can do here? Noise ejection. High frequency reject. Should probably cut it off. Low frequency reject. Yeah, just DC coupling there. So AC coupling on there, no bandwidth limit. Bloody dots. So there's the dots there. So if the dot is actually where sample point is, that should be right. So I'm at the limit there as well of the samples. 2 nanosecond per division as fast as this can go. Yes, it can do show away from 250 megahertz, but I think it's not really doing a good job of it. Its sample rate's too low. Yeah, I think its sample rate's too low for that. I just can't see it reliably. Yeah, you can see it. As I bring the time base down, it actually drops down. So let's go back to 200 megahertz again. It comes up a bit, and still bouncing around. 150 megahertz. Still bouncing around a little bit, but it's improved. So even that, I don't think that's actually great in that way, actually. Quiet menu, remember that stayed on there, still on normal. Go back to averaging again, and it smooths it out, but that's like an artificial way of doing it. So I think even that is pushing it, to be honest. 100 megahertz is starting to play up a little bit there. 50 is better, but yeah, I don't know. It could even be noise. I could put my Marconi back on again. Okay, so back on the Marconi, 50 megahertz. I'll just shut the Rohde Schwarz down. You just heard the power went off, and that's doing the same thing. Now I put this RF level up to the maximum, what I can do, and that is basically there. 150 megahertz, bouncing around the other place. 200 megahertz, and 250 megahertz. I mean, you can see signals, but I certainly wouldn't be measuring them with that. It's just the sample rate is just way too low up there. It's just not going to do it. Yes, you can see the waveform, but I don't think that's right. Let's not set in case there's something I've been playing with which just confused it. Maybe I'm being too harsh with it. No, multi-cycle, single cycle, signal capture. Maybe. We've got another display along here now. So I thought let's check the hold off menu in case that has something to do with this jumping around a little bit. And the lowest you can actually go to is 100 nanoseconds. You can't go any lower than that. The other thing to do, if you've got a value and you want to go back to reset, you can just push it and it puts it back down to 0 or 100. I don't know if it's something to do with this. I can't see any reason for it to be jumping around like this. Not at this frequency, it should be consistent, stable. So this is back at 10 megahertz and it looks absolutely fine. So I think really it's purely the sample rates that just aren't up to it. So yes, it's 200 megahertz scope, but it's not great. I would probably call this a 100 megahertz scope, not a 200 megahertz scope. Shorter bandwidth allows you to see waveforms of the higher frequency, which is only part of the equation. You have to have a high enough sample rate, otherwise without that, no good. So if I go into the system data in the utility here, it says the sample rate is 800 megasamples per second. This is at 10 megahertz. So I'm going to jump back out this menu, go up to 100 megahertz, see what it says then. So this is, just to be clear, so utility menu, system status, and that says 1 gigasample per second. Sample dots 40. Aha. Last time we had 400 sample dots at the 10 megahertz. Now we're getting 40 sample dots. That's why it's jumping around. Now somehow I managed to find this other menu here. I don't know how I found it. I've turned it on somehow. I'm not quite sure how. You must have stumbled across it somewhere in their settings. And it's just showing all of the measurement data. So maybe the fact that this is trying to run in the background, maybe that's what's slowing it down a bit maybe. So I'll turn channel 2 on, and we're now getting 500 megasamples per second and 20 sample dots. Display dots are 800, so obviously what you see on display is not the same as what the samples actually are. So that's a bit of masking going on there. So it's actually hiding what's actually going on. That's obviously to try and give you a better display, more predictable display based on its calculations. But in a way it gives you a false sense of security about what you're actually seeing. So the fact the sample dots are only 20 now, that could be interesting. So can I get back out here? So now that's jumping around everywhere. That's some 100 megahertz input there. And if I go to 200 megahertz, so it's jumping everywhere. If I turn the channel 2 off, hold on, 20 megahertz bandwidth limit's turned on. How's that turned on? I'll never turn it on. Right. Must have done all that setup at some point and it's confused things. Okay, doesn't help. But yeah, that's 200 megahertz and it's not really right. So we go measurement again. Get 560 millivolts. And we're doing 504 on my generator there. So that's not wrong, not really, it's just not right either. It's not getting true representation. That's just a shame, because if it had enough sampling, it would be right. That's what's letting it down. I think I've covered it already, haven't I? Doesn't have any serial decoding and all that. It's just basic oscilloscope function. The front end is doing it, but the sampling rate isn't, and that's what's limiting it, is the sampling rate, which is a real shame. So if it's doing 1 gig sample per second, why is it only doing 40 dots? That's the interesting thing there, isn't it? So a couple of things I didn't really show in here. The filter, so it's high pass, low pass, band pass, stuff like that. You can just flick through those using this option here. You can set the frequencies as well, band pass as well, so you want to do filtering, which is quite a nice feature. Let's get back out of there. So I'm going to do a self-cal. Let's see if this does anything to improve the measurement. So nothing's on the front panel, nothing connected in. Disconnect all probes, cables, blah blah blah. Press F5 to confirm, press F4 to cancel. So F5 to confirm. Let's let it do a self-cal and see if anything comes up. I'll just leave this running, I'll come back when it's done. Alright, self-cal was finished. It took a while, but it's done. Let's plug this back in again, see if anything's changed. Looks about the same. Let's check the measurements again. I might even pull this thing apart, do a teardown, mate. What do you reckon? So it's 50 megahertz, 10 megahertz. Actually, that's looking really accurate now. (10 megahertz, 480 millivolts). Okay, 5 megahertz, 480. That's actually looking slightly better, actually. 1, 40 millivolts again. Okay. 0.5 megahertz, 460 millivolts. Okay, let's go back to 50 megahertz. That's looking good. 500 millivolts, 100 megahertz then. It's actually slightly off there, saying 580, which isn't quite correct. Let's do 200. Let's dip down there, you can see it jumping around again. So it's not changed the issue of the sample rates, obviously. The voltage reading's got a bit more level across the range. Before it's changing by more at the lower end. And here it's actually going up in frequency, which is a bit suspicious. Anyway, well, my opinion of this is basically it's a basic scope. Don't trust the 200 megahertz bandwidth. Yes, sure, it will do it based on the front end input, but the sample rate's not fast enough. It just doesn't do enough. So this is a 1 megahertz input now. Let's go to utility again and look at the status again. 2 button pushes. Sample dots 3200. 800 megasamples per second. So that is actually looking a lot more realistic, and that's why we've got a much better waveform. So that the number of samples it's taking at that lower frequency are absolutely fine. There's absolutely no reason why that would be an issue. 50 is starting to get a bit too distorted for my liking. Yeah, I'd say this is a 50 megahertz scope. In reality, I think the sample rate side of it, 50 megahertz. I'm pretty sure that's what it should be, really, in reality. And that's 80 sample dots there. 80 samples is probably the minimum, I'd say, to get in a decent waveform. I mean, in theory you can do it much less. But this is what I'm seeing on screen, you know. It could just be the way it's displaying, but I don't think so. You can't turn persistence off completely, and you can't turn off the hold off either. There's two things you can't actually turn right off. Unless I have a lot of noise here. That's also possible. Shall I check some other scope just to confirm this? So here's exactly the same waveform, nothing has changed. I've taken the cable from the front of the Hantek, plugged into the front of the Siglent. As you can see, there's the adapter there, and there's the waveform coming out. Dead solid, dead smooth, absolutely fine. So it's not noise on the waveform. And just to be sure, I've plugged the thing into channel 2. There's the same waveform in channel 2, also showing signs of jittering around. So it's not like channel 1's got it, channel 2 also has it. Bear that in mind if you're considering getting this particular scope, or maybe one of the other brother or sister scopes to this, then you might want to consider the fact that yes, it says that frequency there for the actual front end bandwidth, which is a true representation. I don't think that's fake, but the sample rate doesn't allow you to capture the waveform correctly with enough detail, it would seem. That's the way it appears, at least to my interpretation of what's going on the screen here. It's not that noisy. So yeah, so just bear that in mind. If you are considering getting this, then allow for the fact that this, I'd say halve it, 100 megahertz, I'd say probably as the absolute top end if you want accurate waveform measurements on there. Maybe even a bit less, certainly less than 50. Below 50 is absolutely fine. Above 50 is when you're starting to get into that grey area there about whether or not it's really okay. If you're on a budget then, and you don't need to do these high frequency measurements above 50 megahertz, then I think it's probably fine. The interesting thing about the scope as well is that these posts here are actually getting warm. So it's obviously transferring some heat from the power supply out the chassis. It's elevated probably, I don't know, 10 degrees, maybe 15 degrees above ambient, something like that. Anyway, it's pulling it apart. So it looks like it's got 4 screws, 2 here, 2 inside the handle, just inside there. So I'll take those off. Oh, the feet just popped in. Are there any seals on this thing? There's no warranty seals on it. Anyway, let's get the screws out. Threaded insert inside the plastic there. That's the machine screw. Get these ones out. When I'm doing these reviews, I have to try and be fairly unbiased and try and keep a fair opinion of the equipment I'm reviewing. That's not always easy to do because, you know, sometimes you want to make sure that you portray in a fair light the person that's actually giving you the equipment. It's hard to do an unbiased review sometimes. But I do try and do unbiased reviews. This unit is okay on a budget, I'd say. It's not going to compete with a more mainstream oscilloscope with more features like Siglent, so they've got built-in decoding, that sort of stuff. We need other brands out there which do similar sorts of things. So it's just something to consider that, you know, I try and be fair. The fact that I've got this scope for nothing, it doesn't cost me anything, I've got it for free. A power supply there, and this is all warm. This whole casing here is all warm. Tiny little fan over here. That's probably why the whole casing is warm. Fan is small. Probably not moving enough air through it really. Got multiple voltages. We've got 3 volts, minus 8 volts, plus 14 volts I'm guessing, minus 14 volts. No, it's still plus 14 volts. That connector wasn't on there very well. Look at that, it wobbles around. That's not actually locked in place. Well, it is locked on, it's just not a very good connector. Capacitor brands, YTF. What the? Yeah. Yeah, anyway, that's YTF as well, so that's all YTF caps, never heard of them. No isolation slot, but it does have auto isolators and stuff in there. I mean, it's a power supply, it's a budget one. But it's marked as DSO5202 series, so it is designed for this unit. So, how can I get into this front end? It looks like this cover here will come off and leave the rest in place. Let's do that. Just turn around this way, you can see what I'm doing. And not put some screws back in again. Got to be careful not to touch this power supply because it could still be charged, could still be powering it. Capacitors can store a bit of charge, but then the capacitors aren't very big, so maybe it's not that much of a big deal, but you can still get a zap and give you a bit of a shock. Would be nice if the power supply was shielded as well. Help keep the noise down. Just a nicety if it happens. It's not always done, but it helps. Some of the better brands have shielded power supplies. You can see how small this fan is. It's small. What size is it actually? 50mm fan. There we go. And there's the guts of it. It's got an SD card holder in there. Guess it's for programming. It's memory there. Backup battery. Okay, so you go. So I'm going to drag the thing across the side of the camera and you get to see everything. So we have, I don't know, lots of discrete stuff. So you've got a buzzer over here, obviously USB section. This is obviously the Ethernet section, which isn't populated. So that chip there is probably for the Ethernet. Also got some flash there. So there you go, there's a Samsung processor of some kind. So that's more unpopulated stuff that's down there. And obviously the metal cans, it's got the front end in there, which are all bent over and formed in shape, so I have to unbend those to get into the front end to have a look, so I'm not going to do that. A whole bunch of power supply stuff over here, I'm guessing, looks like it. That's where the power supply goes in, it's over here, so it's regulation. It's not much. What can I say? It's kind of what I expect to find in a more of a budget oscilloscope, really. That's all there is to see, I think. Let's put it back together. Okay, another stuff I should have probably looked at is the AC input side of it. So it is earthed to the chassis, but it's got a spade lug, which is nice and tight. But I don't particularly like spade lugs. I prefer things to be bolted, because spade lugs do eventually they get loose, especially with thermal heating and that sort of stuff. It can happen. They'll expand and contract, and gradually they'll get looser and looser and looser, and you eventually can have a bad connection. So I prefer things to be bolted properly with a ring terminal. I mean, for the time being, that's perfectly fine, but in 10 years' time, probably not. So the actual power switch itself here too, it's a double pole switch, it's switching the neutral and the phase together. so that's fine, just dual pole, which is a nice feature. I do like that. Well, it's back together. I'm going to chuck it back in the box and figure out what to do with it. I may even give this away at one day. Maybe on each 20,000 subscribers I'll give it away. What do you reckon? That might be an idea, eh? I've already got 2 nice scopes here on my bench. I don't need another one. I've got this one because I wanted to have a look at a budget scope and actually see what they were like. I've always been quite fortunate. I've managed to buy used high quality scopes. My previous scopes are Tetronics, so I'm used to decent quality gear. Whereas this is a budget scope. So if you're on a budget, this might suit you just fine, as long as you consider the limitation about the bandwidth. I mean, yes, you can read 200 MHz on it, but above 50, I think you're not going to get a true waveform representation as I showed you. Otherwise, I think it's okay. I mean, it's showing there's no serial decoding like on the channels, but then, you know, it's a budget scope. You're not going to get those kinds of features on a scope of this kind of price range in this bracket. So it's always a trade-off, you know, what they include, what they don't, because everything costs money. So in order to get the price down, they don't add features. Would I recommend a scope? It depends. If you know about the limitations, then yeah, sure. It seems okay. It's got some nice features in there. I love the fact the frequency readout was actually accurate. That was quite surprising. It looks like simple enough to get to grips with the user interface, that sort of thing. It depends on your budget. If your budget can stretch to a different scope, maybe go for a different scope. But if your budget's something going to reach to this, I think it'll be okay. It'll do you. If you're a hobbyist, if professional, certainly not. But hobbyist, I think this is probably where it's more targeted. Thanks for watching. Give us a thumbs up, subscribe, click the bell icon, all the usual stuff, and buy some more merch. You know, I've got a cup here. It's down on a shelf down there somewhere. Catch you later. Bye. Okay, so the power is plugged in. Let's see what happens when we push the button.